Alright, so one of the things that I noticed on our quiz was that we had a little bit of trouble when it came to adding and subtracting polynomials, and we sort of forgot how to combine like terms. So what I mean by that is I saw a lot of x squared plus x squared equals x to the fourth, which is not true. So I want to revisit this, and we're going to start by looking at a picture of what is really happening when we're combining like terms. So for example, I've drawn out here two polynomials. So this first one is a visual representation of x squared plus 2x plus 3, right? We see we've got the one x squared, we have two positive x's, and three ones. So that's x squared plus 2x plus 3. And we're going to be adding that to x squared minus x minus 2. So you've got x squared plus 2x plus 3 plus x squared minus x minus 2. Now, if we were to look at just combining like terms here, right? Remember, I have an x squared and I have another x squared for a total of 2x squared, right? If I were to just combine these, I can see I've got 2x squared, then I have 2x and a negative x, which would leave me with just 1x, and then I have 3 and negative 2, which leaves me with just 1. So if I were to add these together, I get 2x squared plus x plus 1. Okay, so the biggest reminder I want to give you is that when we combine like terms, we are only changing the coefficient. We're not changing the variable. So in other words, when I'm adding x squared plus x squared, that just means I have 2x squared. Notice the coefficient changed from 1 to 2 when I added, but the exponent remained 2. It was x squared at the beginning, I added another x squared, I had 2x squared. So keep that in mind. When we're adding and subtracting polynomials, we're just combining like terms. Okay, so I know when we were learning this in class, we practiced with kind of stacking them vertically and adding, but I think it'll actually be easier if we just practice combining like terms. So in other words, we can take this problem, b minus 10 plus 4b minus 3. Let's just remove the parentheses and combine like terms. So I'm left with b minus 10 plus 4b minus 3. And we can go ahead and combine like terms. I've got a b plus a 4b, which would be 5b. And I have a negative 10 minus 3. So that would be minus 13. Okay, I think this might be a more straightforward way for you to practice adding and subtracting polynomials. Let's look at the next one. So we have x squared minus x minus 2. And we're going to be adding 7x squared minus x. So again, we're going to find our like terms. So I've got x squared plus 7x squared. So that'll be 8x squared. Then I've got a negative x minus x. So that'll be negative 2x. And then I have minus 2. So adding these polynomials gives me 8x squared minus 2x minus 2. Okay, let's look at this next one. Now notice this one is subtraction. So we do need to change things a little bit. So the easiest way to do this, if we want to simply combine like terms, is again to change subtraction to addition and just make sure we distribute that negative across every term inside parentheses there. So that negative 4p squared is going to become a positive 4p squared because we're subtracting a negative. Okay, then this negative p would be a positive p, and the positive 3 would be negative 3. So now we have p squared plus p plus 3 plus 4p squared plus p minus 3. So again, we will find our like terms. I've got a p squared plus a 4p squared. So that's 5p squared. We have a p plus p, which would be 2p. And then we have a 3 minus 3, which is simply 0. So we're left with 5p squared plus 2p. Let's do one more example. So here we have negative k plus 5, and again we're going to distribute this negative across both terms here inside parentheses. So I have minus 3k squared, and then minus negative 6, so plus 6. So now I have negative k plus 5 minus 3k squared plus 6. So to write in standard form, we will start with our greatest exponent. So that's negative 3k squared. Then we've got minus k. And then we have 5 plus 6, which is 11. So that leaves us with negative 3k squared minus k plus 11.